Sydney has a problem. Australia's largest city is running out of water, and like most cities in Australia, it has only one major source of this precious resource. In Sydney's case, that's Warragamba Dam, which provides about 90% of the city's drinking water. Whilst Warragamba Dam is very deep, over 100 metres when full, up to 10% of the water is not accessible because there is no deep water outlet in the dam. The Deep Water Access Project is all about making the water accessible by cutting a hole in the base of the dam. JetCut was contracted to design, build, test and operate the tools which were to be used on this historic project, the first of its kind in the world. So in 2005 we took up the challenge to build a system capable of removing an 18-tonne block of concrete from the base of Australia's largest and deepest dam, 80 metres underwater. Now that's quite a challenge, but it was made even more difficult because the block needed to be removed into an alcove only slightly larger than the block itself. This presented a whole range of challenges to cutting and removing it. Because the space constraints were so tight, we had to design a universal main frame which all the tools could be lowered into. This frame also had to be capable of lifting the 18-tonne block once the work was complete. In the first stage of the operation, 90 and 250mm coring tools were used to bore 6 holes in the dam wall. The two 90mm cores were used to place bearing packs underneath the block so it could slide out easily. We then used a specially designed wire saw to cut between the 250mm cores. The block was cut with a 2-degree taper because there was only 10mm of clearance all the way around it. Without the taper, this 18-tonne monster stood a very real chance of jamming on the way out. Space constraints also meant the wire saw was unable to cut through the dam in one pass, as the end of the saw would hit it. So we devised a hydraulic extension system to lengthen the cut beyond the end of the wall. The control system was similar in many respects to that of a deep water ROV, with an oil-filled, pressure-compensated box holding all the control hydraulics and a separate fully sealed electronics pod containing the brain for the tool. The brain, as we called it, had 4 remote cameras connected to a video server. These provided images of the operation. Some of the cameras that were connected gave us feedback on positioning. These cameras were attached to the moving parts of the tools and ran along a ruler, giving real-time accurate measurements of the cutting. The mechanical parts of the tool were controlled by a process computer, which was connected along with a video server to a communications hub. The signals from both subsystems were then broadcast to the surface via a fibre optic link. This link was then connected to 2 topside monitoring and control workstations and the topside process computer. This meant that all operations could be monitored from the surface remotely with no intervention required. A launch and recovery system was specially designed to deploy all the parts of the tools. Here, the main locating frame is lowered to the workface and locked into position hydraulically from the surface. Once the main frame is in position, the first round of coring operations can begin. We start with a 90mm core. All the tools are guided to the main frame along 2 wires attached to the launch and recovery system. A special flushing pump, controlled from the surface, was used to wash debris out of the holes in all the coring operations. Once the first hole is complete, the tool frame is recovered and reconfigured for the second 90mm core. We now have 2 90mm holes which will be used to slide the bearing packs into for the block recovery. The 90mm coring tool is now replaced with a 250mm one and lowered to the workface for the first large hole. Because the 250mm core is in the geometric corner of the block, we need only rotate the tool frame for the next setup. The tool is lowered on the guide wires for the second 250mm coring operation. Once the second large hole is cut out, we recover the tool and set up for the first wire saw cut. We cut this slot first just in case there were problems. It enabled us to move the outlet up 300mm for a second attempt if required. On completion of the first wire saw cut, we recover the tool and set up for the remaining 250mm cores. Once they are complete, the tool is once again reconfigured for wire sawing. We cut the first vertical slot, recover and rotate the tool for the second vertical slot. For the final slot, the tool pack is reconfigured with a block recovery frame on the bottom. This contains the bearing packs which are slid underneath the block. The final slot is cut, the block drops onto the bearings, slides out and is recovered to the surface.